Hello everyone, my name is Elijah Proctor and welcome to my Milestone 2 presentation for the Intelligent Workflow Automation System, also known as IWAS. And so this is an independent project that I've taken ideation through structured SDLC planning and analysis of requirements. And so I'm basically going to walk you through every stage of my requirement specification. This includes the functional and non-functional requirements and the technical foundations of the project. Here's an overview of the project. And so IWAS is created so that we solve a common problem that exists in modern workplaces. Too much time being spent performing tasks that are repetitive and then have to be updated manually. And so this can include pushing Jira tickets to Slack, keeping track of GitHub commits, and coordinating these manual tasks. And so my system connects to Slack, Jira, and GitHub through APIs. And it uses a workflow engine so that we can automate repetitive operations. It's built on a Flask backend, which is Python, a React frontend, and it runs in a containerized Kubernetes cluster, which is going to be eventually hosted on DigitalOcean. And then MySQL serves as the central data storage unit. And this allows us to consistently track and persist the data. The economic justification. So even though I'm performing this project by myself, I wanted to ground it in how it can impact the real world. And so based on the estimates for saving time and reducing errors that occur across task coordination, IWAS could potentially save upwards of $500,000 in collective annual savings, even if deployed to a small group of companies. And so the savings that occur come from improving the visibility of tasks, reducing response time, and avoiding people or employees from context switching among development teams. So this allows people to make the best use of resources and save time. So even though this is a single person project, I'm trying to focus on the tangible outcomes so that we can reflect how this can actually be beneficial to a business. Independent project management, and so since I'm doing this on my own, I try to adopt practices from Agile so that I'm organized and accountable of the tasks that I do. And so I'm using GitHub projects, which is going to be used to break down my work into weekly sprints. And then every sprint is going to be focusing on 1 to 2 user stories. I'm going to track my commits. I'm going to write commits that have descriptive messages and then write down key things that I learned after every single sprint. And so even though I don't have a team, using these processes, it's going to help me approach the project in a systematic way and also maintain version control and stay in line with the SDLC model. SDLC planning and control. So my development process follows an iterative agile SDLC model. For planning, I write every user story and define what the success criteria is for every single one. I keep track of risk factors that could occur and changes, and I use markdown notes in my project repo. So I just write everything down using the markdown language so it looks nice and organized. And then control is going to be maintained through coding reviews of my own commits that I do, and then also performing weekly retrospectives of the progress that I made every single week. And then by doing this is actually a team-based practice, but I'm doing it as an individual. It's making me ensure that structure and consistency exist across every single milestone that I pass through. Functional requirements, and so the entire system is driven by how clear our user stories are. And so here are 4 examples of the main functional requirements for the system. So the first one, for example, is like a developer. As a developer, I want real-time Slack notifications when Jira tickets are updated. Another one is, as a user, I want to be able to configure automation rules so that specific triggers can cause defined actions. And then I also built support for GitHub webhook integration. And then lastly, role-based access controls is enforced. And so these stories help me define what the system should do and what I should prioritize and what is considered to be the most valuable feature. Non-functional requirements. Beyond just having features, IWAS must meet system level limits, and so this includes having an uptime target of 99% or higher, a maximum 2-second latency for the execution of tasks, encrypted API calls, and audits for all the actions that are performed by users. And so lastly, it needs to also scale to handle more than 10,000 API calls per day. And so these non-functional requirements are created so that we can support performance and long-term maintainability of the system. And so these characteristics are actually key for any automation system that exists. Now let's go over the technical requirements. IWAS uses a modern and a lean tech stack. The backend is built with Flask via Python. The front end uses React.js, and MySQL handles the structured data storage. And so our system is going to be containerized and using Docker, and then it's going to be deployed in a Kubernetes cluster, ideally on a DigitalOcean cloud-based system. And so in order to allow for secure and authorized access, we're going to use OAuth 2.0 with JWT tokens will also be implemented. And so our app is going to be connecting to external systems like Slack, Jira, and GitHub using their public APIs. Now let's go over the logical architecture. And so the system is architected so that it can be scalable and modular. Our React front end is going to be speaking with the Flask API gateway, which is going to be used to route API requests and handle the authentication. A central workflow engine processes automation logic that is set up by the end user. We have role-based permissions and OAuth 2.0 enforced access control for security, our security layer. And then data is going to be stored and retrieved from the MySQL backend. And so utilizing this layered architecture is going to be supporting future extensions and also allow for efficient debugging as I make it through the other milestones. User interface design. The user interface is created so that it's created with clarity and productivity in mind. And so our core modules, our first module, or our core module is the dashboard. And this is going to be used to monitor tasks and performance of the system. We have UI for configuring workflows, where the rules and the logic are set. Our settings for integration, where connections to external tools are managed. And so I also created some wireframes that are in the technical and functional requirements documentation. And so this lays out the navigation, ensuring that user interactions are intuitive, even for people who aren't technical. Justification for the design that I created. So Flask creates lightweight APIs and routing, and also it returns data using JSON, which is like what's recommended for communication through applications. We also have React, which allows me to build reusable components and be able to manage state effectively on the front end. Docker makes it easy to containerize the application and deploy it. And then Kubernetes ensures high availability of that containerized application. Every single module in the system is isolated from each other, and so it makes testing, monitoring, and performing future updates a lot simpler to implement without affecting other components. individual development discipline. So I'm doing this project by myself, which requires a lot of discipline. I set goals every single week, and I try to document progress in a developer log. I write commits every single day that are descriptive, and then each change is clearly described. I also journal the decisions that I make, especially key design decisions, and then also challenges that I face, so that I track reasonings behind decisions that I've made, and then the lessons that I've learned throughout the project. And so this is a reflective of practice, and this helps me to simulate like a professional development workflow that could exist in the real world, and it also makes me accountable to the project timeline, so make sure I'm doing tasks correctly in a timely manner. Techniques and testing for the SDLC to make sure that we have a quality product. I'm using PyTest for the unit tests and Postman for integration testing. I wrote these tests out. I wrote tests for user authentication, uh, workflow, rule and logic evaluation, and handling of errors. And so I'm also testing database backups. I'm restoring scripts so that I ensure the data is always reliable. And so even though I'm working by myself, I try to approach testing rigorously so that I can simulate like what a QA team would typically do to test a product. Aligning with the user's needs. The system meets the user's needs in some major areas, which includes automation, which saves time, and then notifications, which always keeps the stakeholders informed and alerted of different tasks. Role control enforces secure access, and then our dashboards give insight into performance. And so these features together reflect the primary goals of IWAS, which is so that we streamline repetitive tasks while also maintaining security and traceability. So this architecture is set up so that it can support future enhancements, which includes AI-driven analytics or mobile integration, which would be a nice addition. In conclusion, this milestone represents the core, the basis of IWAS. I've talked about what the system will do, how it's going to operate, and how it aligns with the real world needs. And so working by myself, I'm adhering to the SDLC principles. I'm using Agile so I stay organized, and I'm creating a strong foundation for the future development that I'm going to be doing. And so I'm very excited to keep refining this project as I'm moving into the design and the implementation phases after. And so thank you for your time. Have a nice day.